Hello and welcome. Really enjoyed watching the videos that you guys made for me. I feel like I know you guys better. I think about about half or a third of the class, somewhere in there, are students that I've had before for honors geometry. Typically like 3 years ago, your freshman year or something like that. So welcome back. If you're one of my former students, I feel like I already know you, and of course I remember you. If not, I hope that you guys were able to watch that welcome video. We're able to feel like you got to know me a little bit better, my personality. It just helps now that when I see your name, it's not just a name. I know how to pronounce it, and I can think of something from the video, something about your personality that I could tell, or something that we had in common. So that's going to make this a lot more bearable for me teaching virtually. So anyway, instead of going through the syllabus and reading that on the first day, which would be so dry, I'm just going to let you guys read it on your own time, and you can go back and reference it anytime you have a question. You can also post those questions if you want, where I posted the syllabus, and I can answer those questions if you had any questions, specific questions about what we're going to be doing this year. So let's go ahead and get started. So I'm going to introduce you guys to statistics. So statistics is not like many other math courses. In fact, there's a lot of vocab in it, and it seems to be really conceptual. I think it's very visual, like geometry. So I'm really glad that I teach geometry and stats. I think both of them are fascinating subjects. This is my third year to teach statistics, which is the longest continuing amount of time that any teacher at Putnam City High School has taught statistics. So I guess at this point I am the most experienced statistics teacher that Putnam City High School has had. So that's kind of cool. And if you are taking the AP test, we have had lots of success with the AP test. So over half my students passed the test last year and the year before. So the first 2 years that I taught it. So that's wonderful, and I think we'll continue to have the success today. If you're in the on-level course, we'll be going at a slower pace than the AP Statistics class. The AP Stat class, we're going through all 750 pages of that textbook, which is going to be a lot, but I'm lecturing through it, so you don't have to read it. So you're welcome. But that's what it takes to get you ready for the AP test. If you're in the on-level class, we'll go slower. We'll spend more time on experiments and in-class activities when we are able to be in class. So we won't be rushing through all the content, because we don't have to get through all the content. We'll do what we can with the pace and the students that we have. So I'm excited that we have two separate classes this year. A lot of my videos will just be the same, like this one, so I just have to make one video. There might be times when I have to make a separate video, or the pacing will be different, and we'll just be using older videos for the on-level kids. So here are, if you read the syllabus, this is a list that you have seen before. So these are examples of fields that use statistics. If you were thinking about calculus, and I love physics and calculus, so don't get me wrong, they're really fascinating, especially, well, physics. I mean, physics is like really cool. Engineering, architecture, all that great stuff. If you want to go into those fields, calculus is probably going to be the most important math course that you take, along with physics, right? But if you're going into any other field that's not engineering or architecture, statistics will probably be the most important math that you will use. And so here are some fields that statistics has very important roles. And after you take this course this year, you will know through examples that we do in the textbook of how the field of statistics is used and applied to all these various different fields. So from looking at your videos that you guys made, a lot of you guys wanted to go into the medical field, or like physical therapy, or one of these fields that we have listed here, or even in ways that you don't know. Statistics is probably involved in those fields. So medical, pharmaceutical, nutrition, physical therapy, psychology, political science, environmental science, criminal justice, which is the example I'm going to give you guys today, biology, business and marketing, actual science, which my brother-in-law does. It's life insurance policies. Makes a lot of money, and it's a really, I think it's pretty interesting, with mortician tables, which we might even get into this year and talk about some COVID stuff, if you guys don't mind, and also quality control in manufacturing. So really good stuff. Let's get on with our example. I've spent enough time just introducing this whole thing. All right, so this is registered nurse Kristen Gilbert. Some call her an angel or even a hero. Others call her the angel of death. Yes, meme-worthy. So there were some growing suspicions around this angel. So during the same year that Nurse Gilbert was receiving accolades for her nursing skills, 3 of her fellow nurses approached their administration. There have been quite a few deaths from cardiac arrest, which is a heart attack. There were several unexplained shortages of epinephrine. But could that be just a coincidence? So epinephrine might sound familiar. So if you have an EpiPen, or you know what an EpiPen is, that is epinephrine. It also goes by another name of adrenaline. So it does something with the blood. I don't do medical stuff, but that's for other people to do. I do stats. So that is chemically what it looks like. I'll stop. All right, so the investigation by the Veterans Administration found the number of cardiac deaths were in line with other Veteran Administration hospitals, so the matter was dismissed. So because the overall number of deaths at this hospital was not significantly higher than what the other hospitals were having, they dismissed the case, and they thought, well, there's obviously nothing going on here with this one nurse, Kristen Gilbert. But the nurses were still suspicious. So the reports from the nurse Kathy Ricks suspected something was wrong. She counted the epinephrine bottles one afternoon, and there were 3. Then there was a cardiac emergency. One of the patients had a heart attack, and when she went back to see if the bottles were still there, she found none of them. So all 3 of the bottles had been taken by somebody. Who could it be? I think we know. But there were 3. Oh, innocent till proven guilty. There were 3 broken containers in the needle disposal bucket. So somebody had been using the epidural needles, and she thinks they might be connected. Another nurse, anonymous, said that she heard the first man who cried out, "Stop, stop, you're killing me," at the time Gilbert was in his room. That would make me very suspicious too. Then Bonnie Bledsoe claimed that Gilbert had offered her some adrenaline when she said that she suffered from asthma, but what was suspicious about it is she pulled it right out of her pocket instead of having to go to a medicine cabinet to get to the adrenaline, the epinephrine. So there was a second investigation that was done by Stephen Gelbach. Yeah, I think I said that right. A statistician, probably got paid big bucks to do this, at the University of Massachusetts, who was brought to analyze the data. That's what we do with statistics. We take data sets, which we'll look at here, and there's different ways to visualize those with graphs, and we'll do our fair share of graphs this year as well, which will be kind of fun, using calculators and also just doing some by hand. And then the real important part is not just visualizing data, but analyzing data and being able to draw conclusions and using probability to make our final statements, which is really, really powerful. And people wish that we could do this, and we actually can using statistics. So based on his analysis of the data, the U.S. Attorney Office decided to convene a grand jury to hear the evidence against Gilbert, to see if there was enough evidence to press to go on with and press charges, I suppose. Anyway, did the patients die from natural causes? This is a big question. So the patients that died, was it from natural causes, or was there foul play? So most of the patients that died from cardiac arrest at the VA where she was working were middle-aged men that did not have any cardiac history. So it's not like they had a history of having issues with their heart. So could the deaths have been from natural causes? The case, while suggestive, was entirely circumstantial. So we got some issues there. So the real question we have is, were these heart attacks naturally occurring, or do we think that she was doing something with epinephrine? Okay. So what would you do? So let's pretend you're on the grand jury. Based on evidence, would you decide to hold her for trial or not? So first thing we want to do is look at the data. So these are the cardiac arrests, or the heart issues that were occurring throughout the years. Okay, so you just looking at this data, we look at our colors. We got the night shift, the day shift, and the evening shift. So it looks like in 88 and 89, it was pretty evenly distributed, right, between the amount of deaths that were occurring on each shift. But it looks like in 1990, it's no longer evenly distributed. It's pretty heavily skewed. Looks like the evening shift was about the same, but the other two like doubled or tripled. So that's kind of suspicious. And then after that, it was just one of those shifts that seems to be higher. And then, yeah, way higher on this one. And then after that, they kind of go back to what they were before, where they're kind of evenly distributed, but we have a lower number. All right, so if there was no foul play here, what would we expect in this graph? Well, we would probably expect all of these to be very close together, right? So whether somebody had a heart attack at night or daytime or the evening, we'd expect it to probably stay the same, or there's going to be variation from year to year or sample to sample, but we'd expect them to be fairly consistent, and there not to be some clear and obvious pattern. But when we're looking at this data, does it look unusual? Is that what we would expect? Going from this year to this year, there's that, wow, that does not look usual to me. I also see a pattern. So we got orange, 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 purple, like duck, duck, goose, right? I should have done it for backwards. That would have been funnier. But anyway, I'm seeing some patterns here. So I'm suspicious. Does this look like a usual distribution of what we would expect? Probably not. But so it is unusual. Now the question we have is, how unusual is this? So if this was an independent thing and it was natural causes of all the samples we would have done, how likely would it be that we would get a sample that looked like this? And we can actually, with probability, put a number to that, and we're going to learn how to do that later in the year. So let's keep moving. The key question is, were there significantly more deaths in the unit when Kirsten Gilbert was on duty than at other times? Is it statistically significant? Is it so unusual that it's very unlikely to have occurred by just bad luck or random chance, right? So 1 or 2 extra deaths on her watch could have just been a coincidence. So how many extra deaths would it take for you to reach this threshold of where it was significant, statistically significant, where we're just throwing out, there's no way that happened by chance, right? So if we're flipping a coin 10 times, we would expect 5 times to get a heads, right? But what if we had 7 heads? Is that unusual? Well, no, that could happen. What if we had 8 heads? Well, that's getting kind of unusual, right? 9 heads, that's really, really unusual. And if you flipped it and got 10 heads in a row, you should probably go to Vegas. You're either really lucky or really unlucky, and you'll find out pretty quick. All right, so the foundation of statistics. In statistics, we gather data, and we look at it, we visualize it is what we're trying to say. We graph it out so that we can see patterns like we did with this data over here. We use probability, which we're going to do later in the year, to determine and quantify, to put a number, a p-value is actually what we call it, of what's the probability of this occurring naturally. And if that probability is really, really low, like less than 1% or maybe 5% or 10%, spoilers, that's kind of what we use, then we would be able to reject the null hypothesis. Whoa, I'm using some vocab that we don't know. We won't know till the second semester, but it's okay because I'm just giving you an example of how this stuff works. And I think it's pretty cool. So then the last thing we're able to do is draw a conclusion based on our data and our analysis. So if our p-value, our probability is so low that this could have occurred by normal variation or normal chance, then we would have to reject the null hypothesis, and we would have enough evidence to call BS and to lock her up, throw her in jail. Okay, so what do you notice and what do you wonder? We kind of already talked about this. We got a spike here with these 2 shifts, and then it looks like this evening shift was kind of suspect, and then all of a sudden it went back to normal. So the first thing that I would want to know is what shifts was she working, and that's what I wonder. And I noticed there's some patterns there that we discussed before. So here's her work records. In 1990, she started working, which is this normal 1990. She started working, and when she started working, it was the night shift. Growing awfully suspicious. And then 1991 to 95, which is here to here, she was working the evening shift, which is orange, right? So purple, orange, 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 orange. And then in 1996, when it went back to normal, she just so happened to quit working at the VA. That looks awfully, awfully suspicious just from the patterns that we were noticing, and then all of a sudden we matched it up, and it matches up exactly with that. So I'm thinking there's something going on here. Besides, did you see her face? She looks evil. So moving on, and if we highlight those shifts that she worked in red, you can clearly see they're significantly higher than the other shifts around her. At least I would say they're significant, but can I quantify that? Well, yeah, that's what you need statistics for, right? All right, so is it convincing enough? Based on the graph of Kristen Gilbert's work schedule, is this enough to convince you of her guilt? I would say yes. You should say yes, because that's the truth. Anyway, spoilers. We want to know if the number of deaths that occurred when Miss Gilbert was on duty is so unusual that it's not likely or probable to have occurred by chance. That's what we really want to know. Is it such an unusual sample, such an unusual statistic that we received from our data that we don't believe that could have occurred by just random chance, like 9 heads in a row or something, or 9 out of 10 coin flips that turned out heads. That would be so unusual. There's no way that occurred by chance. That coin has to be biased. Contingency table. So contingency table is a different way to display the data. So this is not visual. It's just a way to sort through the data. Obviously, we prefer looking at the graph, right? That's much easier to interpret than the data. And so when we're looking just at raw numbers, there's no color in that. I don't like it. It's boring. The slide is boring. I want to move on, right? But I have to tell you about it. So contingency tables when we have two variables going on. So was there a death on the shift? Yes or no? Was Gilbert present? Yes or no? And then we have the margins, which is the totals for all the deaths, all when she was present and not present. And then in the middle here, this is where it gets really interesting. These are the contingent values. So was there a death on the shift, which there were 74 deaths altogether, but is splitting up based on the contingency of whether or not Gilbert was present. So when she was present, there were 40 deaths. When she was not present, there were only 34 deaths. Okay, so that doesn't look like that big of a deal, right? It's just 6 more deaths than when she wasn't on the shift, but she wasn't working all the time. So that's kind of what goes on. Same thing we can look at when there was no deaths on the shift. Only 20 or 217 times that she was present, and 1,000. Wow, I'm having issues with place value. 1,350 times she was not. So anyway, that's how you read a contingency table. I think you get it. But what do the numbers in the table mean? We really want to visualize that because that kind of sucks. So let's make sure we know how to use the contingency table and answer these questions. These are really the only kind of questions we have to do. So if this feels like work, this is really kind of the only work that you're doing today because there's no assignment except for the survey that I'm going to have you guys take because we're going to use that data from the survey, which is totally anonymous, by the way, on Google Forms. So answer truthfully. We're going to use that data and analyze it throughout the rest of this unit. So there's 30 students, I think, in stats altogether and on level and AP. So we're going to have a data set of 30, which is a good number. Statisticians like that number. And we're going to analyze that data. So please answer that. That's really your only homework. And then we'll start the unit with the intro to data on Monday. So just follow along and enjoy the ride. So how many shifts were there total? So total deaths, yes and no. And if we add those two together, that gives us the total in the bottom right here. So there was 1,641 shifts total. How many shifts did Nurse Gilbert work? So was Gilbert present? Yes. 40 of those shifts there were a death, and that means 217 were not. So the total number and the marginal distribution of the shifts that she was present and not present adds up to, that's going to be 200. Ooh, that was a mess. 257. How many shifts had an occurrence of death? So how many of those shifts? I'm guessing they're saying so 40 of those. So what percent of the total shifts had an occurrence of death? Oh, we're looking at the overall death rate, not the contingent one. So how many shifts had an occurrence of death? There were a total of 74 deaths across all of those. So 74 out of the total number of shifts gives us an overall death rate. So the overall probability that somebody would die on any given shift. Ooh, shift. I said shift, right? That was close. That would have been bad. Really bad. It's 4.51%. So on any given day, there's a 4.51% chance that somebody would have a heart attack on average, right? Okay, so we did that. It was math. Ooh, don't do that. Lock, Control K. Done. All right, Nurse Gilbert she worked 257 shifts in the 18-month period, and the overall death rate holds steady. Then how many of her shifts would we have expected to have died? So if the overall death rate is 4.51%, then we would expect 4.51% of her shifts to have had deaths on them. So I'm going to bring out my calculator. By the way, we will be checking out calculators. I think they're planning on doing it sometime next week. And so calculators and textbooks for you guys, they will be TI 84 CE plus or plus CEs, just like this one. So I think you guys will, that'll be really helpful. We have to use these calculators for the AP test and for the entire course. So I'll talk more about those probably in another lecture. But anyway, I'll get that information to you when I know what's going on. I'm coordinating it with Miss Danette right now. All right, so 0.0451, so that times the number of shifts. Okay, so basically 4.5% of her shifts, which would mean we would expect the expected value would be 11.6 shifts. So essentially 11.6 shifts we would expect deaths. So overall, she should have had 11.6 on average. We would expect if it was, totally evenly distributed, we would expect on average 11.6 of her shifts to have had deaths. But how many deaths did Nurse Gilbert actually have? Well, she had 40. Okay, well, we were only expecting 11.6. I mean, if everything was even, like expecting 5 heads out of 10, coin flips, but all of a sudden we got this crazy value like that. Well, 40, I don't know, I'm just going to do some math real quick. 40 divided by 11.6, I mean, I got a calculator doing it for me. That's 3.4 times the number of deaths that we would expect. Does that sound statistically significant to you? Well, then we're kind of talking about like at what point, is it worth throwing somebody in jail? And that value might change for you and me. So we really need to not just kind of guess what that is. We need to be able to quantify what is the probability of that occurring. Well, unfortunately, that math we're not quite ready for, but it is totally possible. And we will, at some point, be able to quantify that using our calculator. So the probability behind it. Later this year, we'll learn how to calculate the odds of how rare this is. The probability of having 40 or more of the 74 deaths occur on Miss Gilbert's shift is less than 1 in a million. Excuse me. It's a very low p-value. So you're saying there's a chance. Anyway, so that's a reference to, I'm tired, I need to go to bed. That's a reference to Dumb and Dumber. Anyway, so that is really, really rare. I would say that is so rare that's unlikely to occur by chance. So statistically significant. We have enough evidence. We should lock her up. In other words, it's very unlikely that Miss Gilbert's shifts were merely unlucky for their patients. There's some foul play going on. So the court case. The grand jury decided that to indict Miss Gilbert. They thought they had enough evidence, so they went ahead and indicted her. She was held over for trial on the accusation of 4 specific murders and 3 attempted murders. Okay, so then the other side, the defense attorney, brought the George Cobb, another statistician. So there's a quote by Mark Twain. He says there are liars, there are damn liars, and then there are statisticians. So kind of the bad rap that statistics gets is that people can kind of twist statistics to say whatever they want. There's some truth to that. We just need to be better statisticians so that we can like critically look at the stats that they did and make sure that they did it all proper. So hopefully by taking this class, you'll be able to kind of call BS on some of the stats that we see out there, and there are a lot of them. So it's fun being in the know, The other side. So they brought in the defense attorney. Judge took note of Dr. Cobb's submission and ruled that the statistical evidence should not be presented in court. What? Why? How come? Because correlation is not equal to causation. So he argued that while he agreed that there was a statistical relationship, there is some association between the two. Even though there is an association, we cannot prove that those two are tied together in a correlation or cause and effect relationship. So we cannot say that it's a cause and effect relationship. There could be some other confounding going on or some lurking variable that was causing them to be higher than what we would expect. So in other words, correlation does not imply causation, which you will hear that phrase over and over, especially in our 3rd unit. Other concerns. Judge was also worried that most jurors were not well versed in statistical reasoning, which is true, but you guys will be, right? And would be confused about what this 1 in a million thing, just like Lloyd Christmas was. He thought he had a chance. And that's not the vibe she was giving. But anyway, what that actually meant. The verdict. Even without the statistical analysis, the jury did find enough sufficient evidence to convict Miss Gilbert. So they actually didn't even need to use the statistics, and they ended up throwing it out. They wouldn't let him use it in the court. The prosecution had asked for the death sentence, but the jury did not agree, so she was sentenced to a life sentence without the possibility of parole. She's currently residing at a federal prison in Texas. Big picture. Statistical thinking plays a big role in our lives. So in all those fields we talked about, this is just one small example of how stats was used in a criminal case, but it is, I believe, of all the, besides geometry, which is like literally the measurement of the earth, which is everywhere. Like practically speaking, if you do remodels or carpentry or anything, you're going to be working with geometry, angles, shapes, measurements. But besides that, in other fields, I don't think there's another math that is as used as statistics. It plays a huge role. And even if you talk to Mr. Lay, our physics teacher, he would tell you that even in engineering, statistics plays a significant role in engineering, which typically you would think would be all calculus based. So don't tell anyone I said this, but I think statistics is probably a really, really important class. And I'm really glad that you guys are taking it. And whatever careers you end up in, I think you will find statistics being used, and you'll probably be required in any master's program to take a statistics course. So I had to take 2 classes of stats in college, but I didn't have it in high school. And so it was really hard for me because it was like a brand new language and I didn't know all these terms. I didn't even know what standard deviation meant, which you might honestly not know either, but we're going to fix that. And I'm glad that you're taking this class. And by the time you get out of here, even if you take it again in college, you'll at least have a base understanding of what stats is all about and some of the terms, so it won't be brand new to you. So you guys are better off than I was, because we didn't offer stats back when I went to high school here, back when dinosaurs roamed the earth. All right, so it should be pointed out, however, in solving crimes, that there's other evidence that's needed for a conviction, not just statistics. And that's it. So trying to make that pretty short. Yeah, our videos, I'll try to keep them short for you. I will also kind of say that if I'm talking too fast for you in YouTube, you got playback options, and so you could slow the video down, you could speed the video up. Also, if you need to go back and look at something again, what's kind of nice is because it's not a live lecture, you can actually go back. So if you like zone out, you get a text or whatever, you like do a tick or a talk or whatever you call that stuff you guys are into these days, you can just rewind 30 seconds. Just be honest, because we zone out. Anyway, I hope you guys have a good weekend. Don't forget to take that survey, and I'll see you guys on Monday.